This is lesson 7.2, add and subtract rational expressions. Our learning objectives are to add and subtract rational expressions with a common denominator, add and subtract rational expressions whose denominators are opposites, find the least common denominator of a rational expression, add and subtract rational expressions with unlike denominators, and add and subtract rational functions. Great, so we have, a handful of objectives today. In our last lesson, 7.1, we worked on multiplying and dividing rational expressions. And so today is about adding and subtracting them. You will be factoring a lot, which you learned factoring skills in chapter 6. So we'll get those back out. Okay, and let's talk about how to add and subtract rational expressions with a common denominator. Okay, so if we have the same denominator, life is really easy when you're adding or subtracting rational expressions. Little reminder for you, rational expression, rational begins with the first 5 letters of ratio. And a ratio in math is a fraction. So when you hear rational in math, you think fraction, okay? And it's a fraction of two polynomials, right? One polynomial divided by another, okay? And so here is how we add and subtract them if they have the same denominator. If P, Q, and R, are polynomials where R cannot equal 0, right? Because R is in a denominator, it can't equal 0. Then P over R plus Q over R equals P plus Q over R. Meaning, if you add two rational expressions together, what you do is you have the same denominator. Well, you just rewrite that denominator there, and then you add P and Q together in the numerator. And you've now turned two rational expressions into one. Same thing for subtraction, right? So here's subtraction of two rational expressions, P over R minus Q over R. Well, that just equals P minus Q in the top, divided by R, the common denominator, in the bottom. Okay? So here's an everyday quote for you to add or subtract rational expressions with a common denominator. Add or subtract the numerators and place the result over the common denominator. Let's look at some examples of this, right? So here I go, I'm jumping into example 7.13, and I see a common denominator, right? X plus 4 is the same as this x plus 4. They're the same denominator in these two rational expressions. And so what I'm going to do is add the numerators together, right? I look at the operation between the rational expressions. There's addition between them. And when we add these things together, we want to put the quadratic terms first, and then the linear terms next, and then the constant last to put things in standard form. We like the powers of the variable to go in order from highest power and then down to least power. And so now I have the x plus 4 common denominator that I write on the bottom. And you'll say, well, okay, we've added the two fractions together. We must be done. And the answer to that is, well, maybe, but no. In this case, we need to then move forward and factor. So our goal is to factor the top and bottom of this rational expression that we now have to see if anything cancels. Okay, so let's look at factoring the top. This trinomial can factor into two pieces, like x plus 4 and x plus 7, right? We're thinking of two numbers that multiply to 28 that sum to 11, and those values are 4 and 7. Great. And now in the bottom, I have an x plus 4, and I notice, wait, that x plus 4 factor, it can cancel with the x plus 4 factor on top. So once we've factored, we are allowed to cancel factors that are common in the numerator and denominator. So this all simplifies to a final answer of x plus 7. Now we're done. Okay, and what was left in the bottom was an invisible 1, right? 1 times x plus 4. There was an invisible 1 that was there, and x plus 7 over 1, well, the division by 1 just becomes invisible. Great, let's move on, and instead of adding two rational expressions together, let's subtract two rational expressions. And I look at it and I say, well, oh my goodness, the denominators are exactly the same. They're both x squared minus 3x minus 18. And one thing about the minus sign here that you always have to be aware of is that minus sign distributes to all of the terms of the numerator. And so it flips all of their signs as you perform this subtraction. So please be careful. Now, I rewrite the denominator, x squared minus 3x minus 18. And I simplify the numerator, like I have 5x squared minus 4x squared. Those are like terms that simplify to 1x squared, right? 5x squared minus 4x squared is 1x squared. And now I look at the linear terms. Negative 7x minus 1x, that's negative 8x. Okay? And lastly, I look at the constant terms like positive 3, and then there's a minus negative 9. Well, this minus sign flipped that negative 9 to positive 9, and 3 plus 9 is 12. So I put a plus 12. Great. So now that we're at this point, we say, well, I've done it. I've simplified these two rational expressions into one with, subtracting one from the other. Am I done? The answer is no. You now need to factor the top and bottom to see if there are any factors that cancel. And some of you will accidentally kill kittens right here. You're going to take those x squared terms and try to cancel them. That's illegal. That is what it is to kill an innocent kitten. If you do that, some innocent kitten dies or some innocent puppy. Please don't do that. So what we're going to do instead is we're going to factor everything we can. And the numerator, x squared minus 8x plus 12, it factors to x minus 6 times x minus 2, right? Because negative 6 times negative 2 is positive 12, and negative 6 plus negative 2 is negative 8. So I'm showing you why. Now I look at the denominator, the bottom, and I say, well, how would I factor that? Well, that would be an x minus 6 times an x plus 3. Because, once again, negative 6 times positive 3 is negative 18, and negative 6 plus 3 is negative 3. And, well, good thing we factored, because it looks like there's a common factor of x minus 6 that cancels on top and bottom. You see no kittens died. That's not illegal. You can cancel factors. That's a great thing. And so now my final answer is just the factor x minus 2 on the top divided by the factor x minus 3 on the bottom. And there we have it. And, whenever you only have one factor remaining in the top, you can drop the parentheses. You don't have to write the parentheses anymore, right? One factor on the bottom, these parentheses that are there, you can just drop them. Okay? Great. So, yeah, we just discussed how to add or subtract two rational expressions with a same denominator. And now something very similar to when they have the same denominator is when they have opposites for denominators. So this next objective is to add and subtract rational expression whose denominators are opposites. Let's do a quick review of what opposites are from our last lesson. Well, if I have like a binomial a minus b, its opposite is b minus a. These are opposites of each other. A minus b is opposite of b minus a. Okay, great. And one important thing is that we can actually make these two things look the same, even though these aren't the same. But what we can do is we can factor out a negative 1 out of this to flip the direction or flip the location of the two terms. Okay, so if I factor a negative 1 out of b minus a, right here I factored out negative 1, then inside it switches the terms and I have a minus b, so it looks exactly like this. And that's really useful, and that helps us to get a common denominator. Great, so let's go ahead and look at this example here, example 7.15, and you'll see what I do. So here I have m squared minus 6m over m squared minus 1 minus 3m plus 2 over 1 minus m squared. I look at the denominators. Are they the same? No, they are opposites. M squared and 1, they've been flipped. Now it's 1 and m squared with the minus sign between them. And so what I can do is I can factor out a negative 1. Okay? And now I can switch the locations of those two terms. But when I factor out a -1, that causes this minus sign right here in the expression to change signs, right? So I can write that minus, here's a minus -1, and so this actually becomes positive, and I can make this now disappear. Great. So now that I've done that, I have the same denominator, right? M squared minus 1, M squared minus 1, but this minus became a plus. It changed opposite sign. And now I can proceed. Because I have the same denominator, we can now, do stuff really nicely. So I've got that m squared minus 1 common denominator. Let's look at the numerator and see how that simplifies. Well, I've got the quadratic term, right? The highest power is 2, so that's called the quadratic term. We write that first. And then the linear terms are negative 6m, and we add 3m. And negative 6m plus 3m is negative 3m. And now I have the constant plus 2. That was the only constant in the numerator. And there you go. I've now taken these two rational expressions and I've written them as one rational expression. I have simplified things. And you would ask, am I done? Nope. It's time to factor. So let's factor everything we can. And one thing you might observe is that the denominator is the difference of squares. M squared minus 1, well, 1 is 1 squared. So this is the difference of squares. And so you've learned that factoring. I'm not going to slow you down. There it is. And the numerator, well, that's going to be m plus 3 times m minus 1 when I think about its factoring. Actually, no, it's m minus 2 times m minus 1. That is what it is when I think about its factoring. There we go, all fixed up. So now I look at it and I say, well, do any of the factors cancel? And the answer is yes. M minus 1 kills m minus 1. And so, we had a cancellation that occurred of factors. And now the only factor that remains on top is m minus 2. And the only one on bottom is m plus 1. And so that's my final result. And I dropped the parentheses since they were the only factors. Great. So when you're dealing, the moral of the story is when you're dealing with opposites for denominators, you can factor out -1, flip the sign in between, and then proceed like normal. Well, our next objective is to find the least common denominator of rational expressions. And so, up to this point, we've had a common denominator, common denominator, common denominator. We made this one a common denominator by factoring out -1. But what if we can't make them common denominators? How do I add and subtract rational expressions then? Well, let's follow this three-step process to find a least common denominator, an LCD, right? So when you see least common denominator, oftentimes your math instructor will call it the LCD. Great. So step 1, factor each denominator completely. Step 2, list the factors of each denominator. And step 3, write the LCD as the product of all factors, but do not include common factors twice. Okay, so if there are common factors in both denominators, do not include them twice. I'll show you how it's done. So in example 7.16, it asked me to find the LCD of the expressions, and I look at this denominator and I say, well, I can factor that. Okay, we're just always trying to factor these days. And, I look at it for a second and I say, well, that's going to be x minus 3 times x plus 1. And now I look at this next denominator and I factor it, and that's going to be x plus 3 times x plus 1. So there you go. We have factored the denominators, right? That was step 1. Factor each denominator completely. Now, step 2 is list the factors of each denominator, right? So are there factors that they share in common, these two denominators? Yes. There's an x plus 1 and an x plus 1. They share a common factor, right? So the LCD in this case, the LCD, is going to be just the factors that are unique, we could say. So I have an x minus 3, which is unique to x plus 3, which is unique to x plus 1. So these are the three factors that are unique: x minus 3, x plus 3, and then the x plus 1, which was repeated twice, but I only have to show it once. Okay, so this is how I find an LCD of two fractions. Now, what I can do is rewrite these rational expressions here and here as equivalent rational expressions with the same denominator, right? Because we're going to try to make denominators the same. So if I see this 8 over x minus 3 times x plus 1, yeah, this fraction right here that I'm dealing with, and I wrote this stuff in factored form. Well, what's it missing that the other rational expression has? Well, it's missing an x plus 3. It doesn't have an x plus 3. It's got an x minus 3 and an x plus 1, right? But it needs the x plus 3. And so what I'm going to do is I'm going to multiply the x plus 3 to the bottom and the top. Great. So that's how I make things work for what we're about to do. And so now if I think about this second rational expression here, you know, I have the rational expression, well, it's 3x, and it's divided by the x plus 3 times the x plus 1. Well, what piece is it missing that the other fraction had? Okay, it has an x plus 3 and an x plus 1. What it doesn't have is an x minus 3. It's missing an x minus 3. So what I do is I take that factor x minus 3 and I multiply it to the top and the bottom. And now what I've done is I've taken these two fractions and I've made it so they have the exact same denominator. Look at that. They have the same denominator. Okay, so we need to be able to do that for the coming objectives today, right? Be able to make the same denominator. Why do we do that? Because now that we have the same denominator, we can add or subtract fractions, right? Because now they have the same denominator. That's our objective. These did not have the same denominator. We made it so they had the same denominator, and now we can proceed with what we already know how to do. So now let's discuss adding and subtracting rational expressions with unlike denominators. Okay, how do you do that? Step 1, determine if the expressions have a common denominator. If they do, go to step 2 right away. If they don't, then you need to find the least common denominator and rewrite each rational expression as an equivalent rational expression. Then step 2, add or subtract the rational expressions now that you have a common denominator. And step 3, simplify if possible. All right, so this is the step process that I will be using for a variety of examples here because we need practice. And so I'm going to practice this all with you, this skill. And so let's just jump into it. And let's say, okay, we need to add these rational expressions and they have different denominators. Okay, so what we're going to do is we're going to find the LCD. And in this case, it's very easy. The LCD is just going to be the product of the two denominators, x minus 3 and x minus 2. And I'll write that maybe on the side here. I'll write the LCD. Where's a good spot? The LCD is going to be x minus 3 times x minus 2. Like that. It's going to be the product of these factors in the denominator. Now, I asked myself, what piece is the first fraction missing? Well, it's missing an x minus 2. So I multiply an x minus 2, not just on the bottom, but on the top. And now, what's this denominator missing? Well, it's got an x minus 2. It's missing the x minus 3. And so I multiply an x minus 3 on bottom and on top. Okay? And this has allowed me to have a common denominator, right? Now my two denominators, they're the same. They're x minus 2 times x minus 3. X minus 2 times x minus 3. They're exactly the same. And since they have the same denominator, I can add the fractions together. Okay? So I take my x minus 2 times x minus 3 denominator, okay, and that becomes my resulting denominator. And now thinking about this, I would need to distribute this 3, multiplying it into both these terms right here. So 3 times x is 3x. And then I have the negative 2 times 3, which is negative 6. And now I see the operation of addition right here. This is important because if this was subtraction, I'd have to distribute it with the 2 into both those things. But in this case, it's addition, so I don't have to worry about it. So I add a 2 times x and a 2 times negative 3 in the top. 2 times x and a 2 times negative 3, which is negative 6. Cool. Now that we're at this point, it's time to combine any like terms, if there are any. So I look, are there any like terms here? Okay, so, well, there's a 3x plus a 2x, and that gives me a 5x, right? So we've got a 5x. And then there's a negative 6 minus 6, which gives me a negative 12. And that's all divided by the x minus 2 times the x minus 3. And this is my final result. It can't be simplified any further. That is as far as it goes. All right, so that's it. Let's keep going. Let's try some more, see how things go. So I see this rational expression, and I'm adding it with this rational expression, and the denominators are not the same, they are different, so I'm going to factor each one. So going in here, I look at this and I say, well, this is x minus 3 times x plus 1. So you're getting out those factoring skills. This one, it's x plus 3 times x plus 1. Great. So whenever you see a denominator that could be factored, factor it immediately. Now, I ask myself, what does this denominator not have that this one does? And the answer is, well, they both have x plus 1. This one has an x minus 3. Well, this one has an x plus 3 that this one doesn't have. And so I'm going to multiply on an x plus 3 on bottom and on top. Okay, but also, you see this fraction, this denominator, it doesn't have an x minus 3. It's missing an x minus 3. And so I multiply an x minus 3 on bottom and on top. And what have I just done? I have made it so that we have the same denominator. Look, the denominators are the same. They have an x plus 3, yep. An x minus 3, yep. And an x plus 1. So they have all the same factors. And because of that, we can now add these two fractions because they have the same denominator. So let's go ahead and write everything out. Okay, so we're going to have a resulting fraction that has all of the factors, all three factors of that denominator. And you might ask, does it matter the order with which I put those factors? It does not, because multiplication is commutative. It's commutative, meaning it doesn't matter the order with which you multiply things. And so now let's distribute the 8 into the x plus 3, and we get an 8x plus 24, right? Because 8 times x is 8x, and 8 times 3 is 24. And we see that the operation of addition is happening. Okay, so we don't have to worry about distributing a minus sign into everything in the second fraction. That's great. So I just put a plus sign, and now I move on and I multiply 3x times x and 3x times negative 3. And 3x times x is 3x squared, and 3x times negative 3 is negative 9x. And there we have it. Okay. Well, now that I've gotten to this point, I need to look at my numerator and simplify it where possible. Okay, so I see like terms, and I'm going to restructure it so that it's in order from greatest power of the variable to smallest power of the variable. I'll do it right down here. I'm going to do it just right here. Okay, so I have a 3x squared that I see, and then I have an 8x minus 9x, which is a negative 1x, and then I have the positive 24 right here. And then in the bottom, I still have all those same pieces, the x plus 3 times the x plus 1 times the x minus 3. Great, so we've gotten to this point, and the question is, well, is this quadratic factorable? Can I factor that quadratic further? And I think about it for a second, and nope, it's not factorable. And so this is how I will leave my final answer. Okay, you can leave the denominators in their factored form like we've been doing. See, it's in factored form, that's just fine. So feel free to leave things in a factored form and you'll be good to go. Okay, so there's our answer. We're ready to move forward into another example. So here I see 8y divided by y squared minus 16, and then a minus 4 divided by y minus 4. I suggest you factor whatever you can in the denominators immediately. So when I see y squared minus 16, I see the difference of squared, right? The difference of squares, because 16 is 4 squared, and so I write the factored version of the difference of squares. And now I have factored this denominator to this. Okay, this stuff, y squared minus 16. Y plus 4 times y minus 4 is the difference of squares. And what's great is I see that this fraction right here has a y minus 4 just like this one does. But this fraction does not have a y plus 4. And so I'm going to take that y plus 4 factor and I'm going to multiply it on top and on bottom like this. I'm multiplying it on top and on bottom. And what's great is I now have a common denominator. Yes, my denominators are now the same. I've got the y plus 4 and the y minus 4, the y plus 4 and the y minus 4. Remember, order doesn't matter for factors. Great. And so now what we can do is we can combine these two rational expressions into a single rational expression with the common denominator of y plus 4 and y minus 4, like this. And the top, let's go ahead and clean that up. So I have an 8y. I'm just going to rewrite it over here because I didn't multiply anything extra to this fraction, right? So I still have just that 8y. And here's where you need to be really careful. You're not just distributing this 4 into both these terms. You're actually distributing the negative 4 into both these terms, right? So it's important that you realize, hey, this isn't just 4. This is negative 4 that you are distributing in to these two terms. Okay, and so you'll get a negative 4y and then a minus 16. That's very important. Cool. And so we get to this point, and let's combine like terms in the numerator, right? Like this 8y minus 4y, well, that reduces. All right, so I'm going to reduce. That becomes, 8y minus 4y is just 4y. And then I have the minus 16. At this stage, always look, as we go and we're working on factoring, always check for GCFs. We've said that in the past, greatest common factors. So this numerator, 4y minus 16, has a GCF of 4, right? So I can factor out a 4, and I'm left with y minus 4, right? Because think about that. If I distributed this back in, 4y minus 16, that's what it would be. So I factored out the GCF of 4. And why would I want to do that? Because I want to see if there are any factors that cancel on top and bottom. In fact, this y minus 4 cancels that y minus 4. And so I've been able to reduce my result, simplify it even further. And so my final answer is, just the factor of 4 on top and the factor of y plus 4 on the bottom. And since they're the only factors, I can drop these parentheses. I don't have to worry about parentheses if I just have one factor on top or on bottom. Great. Well, let's keep practicing a little bit more. It's critical that you have exposure to how this gets done. All right, so when I see negative 3n minus 9 over n squared plus n minus 6 minus n plus 3 over 2 minus n, I immediately factor the bottoms. And I say, okay, well, what's n squared plus n minus 6? Well, wouldn't that just be n minus 2 times n plus 3? Yep. And I see an n minus 2 here. And then I see something funny. Look at this. This is 2 minus n. Wait a second. Those are opposites. And so when you observe opposites, you can immediately factor out a negative 1 and then turn it into n minus 2, right? So I can make this binomial that's the opposite of this, I can make it the same as that if I factor out a negative. But when I factor out a negative, this minus and this negative here for this negative 1, well, they fight and die to make this become positive right here. So I'm going to change this minus sign to a plus sign, and then I can get rid of that negative 1 factor. Great. Now that we have this all set up, we're going to now look at these denominators. I've got n minus 2 and n plus 3. Here I have n minus 2. What's this one missing? It's missing the n plus 3. So whatever's missing, I need to multiply it on top and on bottom, right? So I multiply the n plus 3 factor to the top and the bottom of this fraction. Great. Now we have a common denominator, and so we can proceed. So we'll write the n minus 2 times the n plus 3 on the bottom. That's the common denominator. And on the top, well, we've got the negative 3n minus 9. So I'll write that, negative 3n minus 9. And we've got this binomial times this binomial, n plus 3 times n plus 3. So what I recommend you do at this point is FOIL. Okay? We like to leave the denominator in factored form, right? But we need to clean up the numerator. And to clean up the numerator, we need to FOIL these together. So I have a plus n squared, right? Because n times n is n squared. And then a plus 3n, and then another plus 3n to make 6n. Let me show you. I took n times 3, that's 3n, and then plus 3 times n. Okay, so 3n plus 3n is 6n. So I've simplified it really quickly here. And then 3 times 3 is 9. So I get a 9. And looking at the top, I notice that I can simplify this, right? I can combine like terms. I can clean it all up. So I'll do that. I've got a positive n squared. I've got negative 3n plus 6n. These linear terms, they make positive 3n. And I've got a negative 9 and a positive 9. Ooh, that's exciting. Let's get out my red canceling pen because negative 9 plus 9 cancels. And so I have that numerator now, and I've still got my n minus 2 times n plus 3 factored denominator. And I look at the numerator and I ask myself, can I factor that? Is it factorable? And the answer is yes, it has a GCF. Okay? So always look for a greatest common factor because the GCF is n, and I'm left with an n plus 3, and that's divided by n minus 2 times n plus 3, and then you get really excited, like I do, because these factors can fight and die. No innocent animals were killed when that happened. And so my final result is n divided by n minus 2. There's my final answer. I'll write it up here. N over n minus 2. And some of you may be thinking, wait, couldn't I just take this n on top and cancel it with the n on the bottom? The answer is no, do not do that. That's illegal. Stop it. We cannot cancel terms. Okay, so don't do that. Leave them there. Great. N over n minus 2, final answer. Let's look at another example. This is 4 over this trinomial minus 3 over this trinomial. The trinomials are not the same, so let's factor both of them to see what factored pieces we're dealing with. And so I take this and I turn it into a plus 5 times a plus 1. And I take this and I turn it into a plus 5 times a plus 2. There we go. And so here I have factored this trinomial into this trinomial into this. And now I ask myself, what's missing from these terms that these terms have? And the answer is a plus 2, right? So both of these have an a plus 5. This one has an a plus 1. It doesn't have an a plus 2, right? So I'm going to go and tag on an a plus 2 to the top and the bottom of this fraction. And then what is this denominator missing? It's missing the a plus 1 factor. So I have to multiply on the a plus 1 factor, but I don't just do it to the bottom, I do it to the top as well. Okay, and so now we have a common denominator. We got it. So let's go ahead and write a result with the common denominator of a plus 5 times a plus 2 times a plus 1. And then let's clean up the numerator. Now's the time to clean up the numerator. So yeah, we're going to distribute this 4 to get 4a plus 8. 4a plus 8. And here you need to be very careful because do you see this minus sign? We're not just distributing 3 in, we're distributing negative 3 into a and 1. Okay, so negative 3 times a is a negative 3a. And then negative 3 times 1 is negative 3. There you go. So please be very careful. Always look for the sign, the operation that is happening between the rational expressions. Great. And so now we have our result. It's right here. And we need to do a little cleanup. So let's clean up the numerator. Always leave the denominator factored. You can just leave it factored until the very end. Okay. So the denominator just stays fact. Don't multiply it all out. That's no fun. Okay, and so now I have 4a minus 3a, which gives me a 1a. And I have an 8 minus a 3, that gives me a positive 5. And then, maybe I wrap that in parentheses for fun so I can see that this a plus 5 cancels this a plus 5. And whenever all of the factors cancel on the top or the bottom, there's an invisible one that appears. Okay, so there is, multiplying anything by 1, right, is that thing. So every factor always has an invisible 1 somewhere in front of it. We can make it appear. And so the answer and final result, I'll write it down right here. It's 1 over a plus 2 times a plus 1. This is the final result. Great. So sometimes students think, hey, I canceled that a plus 5, and there's nothing left in the numerator, so that's a 0. No, 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 no. There is an invisible factor of 1 always when you cancel terms. Great. And we're going to look at one more example in this set of examples. And here it is. I've got not just one addition or subtraction. I'm subtracting 3 rational expressions instead of just 2. Right? So every one that we've done up here, 2 rational expressions, 2 rational expressions. Boom, 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 boom. Now we've got 3 rational expressions. And the objective is the same. We want to make the denominators the same. We want to find the same denominator options. So let's work on factoring the denominators. And this denominator, it's already factored. U minus 1, it's factored fully. U for this denominator, it's already factored fully. And this denominator, it has a GCF. And its GCF is U, right? Both these terms have a U in common. And so U minus 1 is the remaining stuff once I factor a U out, right? Because think about it, if I distribute u back in, I get u times u, which is u squared, and u times -1, which is negative u. All right, so that is the factoring. And what's so great about that is I see that there's already a u factor in this denominator, and there's already a u minus 1 factor in that denominator, right? So some of the same factors are going on. Rewriting this out, I have the 2u divided by u minus 1 right there. Well, what is it missing? What factor is it missing that the other ones have? Well, it's missing a u. Okay, so I'm going to take that u minus 1. I'm going to multiply it by u, and I'll do it in red. Okay, and when I do that, I also have to multiply that on top of the first fraction as well. Moving on to the second fraction. I see the operation of addition, so I put addition, and I have 1 over u, right? So that's a 1 over u. Well, what is it missing? Well, this fraction has a u minus 1. This one has a u minus 1. So, well, we need a u minus 1. And I'll do that in red. I'm going to multiply on a u minus 1 on top and on bottom. And now moving on to the third fraction. First of all, I have a minus sign, right here. So I'm going to apply that. And now I have the 2u minus 1 on top. And I have the u times u minus 1 on bottom. And guess what? This fraction already has both the pieces that the other ones have. It has a u and it has a u minus 1. These ones also have a u and a u minus 1, u and u minus 1. So I don't need to add anything else to this one. It's already got everything. Okay, and so now that I have got a common denominator, right? Same denominator here, here, and here, I can rewrite everything as a single fraction where I have u times u minus 1 on the bottom. And let's clean up the numerator. The numerator, we start to clean it up. Well, 2u times u is 2u squared. U times u is u squared, agreed? So there you go, we wrote that out. Now we have this plus sign right here. This plus sign gets written down, boom. And now we have the distribution of 1 into both these terms. Well, 1 times u is just u, and 1 times -1 is -1. Okay, now this is where you have to be really careful because this minus sign right here has to distribute to the 2u and the -1. So being careful, we have a -2u, and then negative of -1 is +1. All right. So at this point, now we just need to clean up the numerator, right? Don't even look at the denominator. Keep the denominator, that denominator that we have. Okay, there it is. But I have a 2u squared. And then I have the positive u minus 2u. U minus 2u is -u. And then I see a -1 and a +1. Well, they're opposite signs, right? Same value, opposite sign, they cancel each other. That's kind of nice. Now I look to see if there's a GCF in my numerator. Can I factor my numerator further? The answer is yes, they share a u in common. So I factor out the u, and I'm left with a 2u minus 1. Okay? And my denominator is still that u times u minus 1. And what's great is this u factor kills that u factor. They cancel each other. And so my final result is 2u minus 1 divided by u minus 1. And yes, some of you will be very tempted right now. You're going to say, well, there's a -1 and a -1, and there's a u and there's a u. The answer is 2. No, that's totally illegal. Don't do that. Okay, we can cancel factors. We cannot cancel terms. Okay, so that's the final result, 2u minus 1 divided by u minus 1. Well, let's apply this really quickly as we finish to functions. Okay, so We've been talking about, dealing with functions, and we can have a rational function, like we discussed in our last lesson, r of x. Why would we call it r of x instead of f of x? Because we're talking about a rational function. So let's call that r of x. Okay, we can name a function whatever we want to. But let's say we have two functions that form r of x. They're f of x and g of x. And we're taking f of x and subtracting g of x, and they're both rational expressions, right? F of x is a rational expression, g of x is a rational expression. So what we can do to find r of x is take the f of x stuff and subtract, right? That we're being asked to subtract the g of x stuff. Okay, and at this moment in time, we look at the denominators and we notice they're not the same. So we need to factor everything we can. Okay, and here I'm going to play with something for just a second. I'm going to make this stuff blue. Great. But this x squared minus 4, that's intriguing to me because that's the difference of squares, right? Because 4 is 2 squared, right? You could write 4 as 2 squared, and that's the difference of squares. And so you get an x plus 2 times an x minus 2 when you factor it, like that. Well, that's interesting because this fraction already has an x minus 2. Look at that, x minus 2. So this thing is only missing an x plus 2, right? That's the only piece that's missing from this fraction. So I'm going to multiply the x plus 2 on top and on bottom. Okay, so I'll do that just really quickly here. X plus 2 gets multiplied on top and on bottom there, like that. Cool. That means I can now combine my two fractions into one since they have the same denominator. That same denominator is x plus 2 times x minus 2. And my numerator, well, I've got to play with all that stuff, right? The top of my fraction, like I need to FOIL x plus 5 times x plus 2. So I'll FOIL that quickly. X times x is x squared. And, well, x times 2 is 2x, and 5 times x is 5x, and 2x plus 5x is 7x. So I'm doing the outer and inner terms of FOILing, and I'm combining them together right away. And then 5 times 2 is 10. Great. Now, be very careful. We have the minus sign of the, between the two fractions. So that has to distribute to both of the terms of the numerator, and we get a minus 5x and a minus 18. Great. We're almost done. All we need to do is simplify the numerator. So the numerator becomes x squared, and 7x minus 5x is a positive 2x, and the constants 10 and negative 18 make negative 8. And so here I've got a result. The only last question to ask, is this quadratic factorable? Can I factor that further? And the answer, it looks like yes. Yeah, let's go ahead and do that. And so I look and I say, well, what if I did like x plus 4 times x minus 2 for the numerator? Well, 4 and negative 2 multiply to make negative 8, and they sum to make positive 2. So yep, that works. And then in the bottom, I have an x plus 2 times an x minus 2. And I see a common factor on top and bottom, so I get out my canceling pencil and I cancel them, and my final result is x plus 4 divided by x minus 2. That's what the r of x function is. Remember, we were trying to find originally the r of x function, and we've simplified it and made it look very, very nice and compact. It's just the factor x plus 4 on top and the factor x minus 2 on bottom. And that makes me feel really good. So guys, thank you. I hope you have a wonderful day. Thank you for learning with me in this lesson, and take care.